All right, so problem number 38 in 1.5. We have two tanks. The rate of input and output is always the same, so that makes our equation simple. So we're always going to use 5 for all of our rates. That also makes it so that our volumes are always constant. The first tank will have 100 in it, and it will always stay at 100. The second will have 200, and it will always stay at 200. Now we use X to first solve for the amount of salt in tank 1, and that's what you'll see through these first few slides. And then once we have that, then we can solve for Y, which is the amount of salt in tank 2. And that's what you'll see. And I've done all that for parts A and B of this problem. And so you can walk your way through these things until you get to this point where we've figured out Y, which is the amount of tank in salt 2. And so question C says, when will find the amount, sorry, let me find the right question here. Find the maximum amount of salt ever in tank 1. So basically what we have to do is maximize this equation, because remember this is the equation that gives us the amount of salt in tank 2. So maximize it. Remember how we maximize an equation, find the maximum of an equation, is we need to find the derivative of this, set it equal to 0, and solve. And so I'm going to find the derivative of Y. So there we go. There's the derivative of Y, and you can follow the chain rule where I differentiated each of these exponential functions. There is the derivative. I want to set it equal to 0 and solve in order to find the critical points. So I have to solve this equation equal to 0 to find the critical points, which is where the maximum happens. The trick here to solve this equation is to factor out the smallest power. So I'm going to factor out this e to the negative t over 40 from both terms, right? Factor it out, and that leaves you with this. Okay, again, we're solving when this equals 0. And this never equals 0, so we really just need to figure out when does this piece equal 0, and that's what you have here. When does that equal 0? And that's pretty straightforward to solve. You'll see that on this slide here. Just solve this equal to 0, right? Just move everything around and isolate t. You end up getting t equals 11.51. So that tells you that after the maximum happens when at time 11.51 minutes. But the question was, well, what is the maximum? And the way you find that is by plugging 11.51 into the Y equation. And that's what you see here. And you end up finding out that the maximum amount of salt, which happens at 11.51 minutes, is 56.25. I guess we're dealing with pounds. Yeah, pounds of salt. And there it is.